Let's now do an exercise together and run a Cox proportional hazard model in SAS. A sample of patients were followed for 2 years in a study to investigate survival after transplant surgery. Patients were followed until death or termination of the study. The variables included in the study were age, that is age at surgery, SERV, that is days from surgery to death, that is the event, status, 1 for those who died, and 0 for those who did not die. Type is the type of transplant, where 1 equals lung transplant, 2 equals heart transplant, and 3 equals kidney transplant. Stay, that is the number of days of post-operative care in the hospital, that is after transplant. This is the data that has been entered into SAS. The name of the data is EPI. We have our variables under the input statement and the actual data under the cards statement. This dataset is also available to you as a SAS file. So here are some questions that we are going to answer using the Cox proportional hazard model. The first question is, does length of post-operative stay impact hazard of death after transplant after adjusting for type of transplant and age? Second, if we wanted to do this analysis for just heart transplant, what SAS statement could you add to do this? And finally, we have to show an output that is maximum likelihood estimate stable only for those who had a heart transplant. So here is a SAS code followed by the SAS output, which we are going to use to answer our question number 1, which was, does length of post-operative stay impact hazard of dying after transplant after adjusting for type of transplant and age? We will use procfrag data is equal to epi, class type reference is equal to 1. We have to use the class statement here because the type variable, that is type of transplant, is a nominal categorical variable in our data set, and we need to assign a reference using the class statement. I have randomly assigned 1 as a reference. However, you can use 2 or 3 as a reference as well. Our model would be model serve into status, where 0 stands for censored observations, is equal to stay, that is the post-operative stay, type of transplant, and age. Age is the continuous variable here. The option RL will give us the hazard ratio confidence limits, whereas ties is equal to F1 specifies the method of handling ties in failure times. You don't need to worry much about ties is equal to F1 at this point, but remember that this is the most common option used to handle ties in failure times. In the output, you can see that hazard ratio for stay is 0.893 with a confidence limit of 0.830 to 0.961. This hazard ratio can be interpreted as the hazard of dying for those who stay 1 day longer post-operatively is 0.893 times lower compared to those who stay shorter, adjusting for type of transplant and age. The staying longer in the hospital after transplant is protective. You can see the p-value is 0.0025, and as the confidence limit does not include 1, we can say that there is a significant association between length of post-operative stay and the hazard of dying. So let's look at the SAS statement that we need to use if we want to do this analysis for just heart transplant. So we could add a where statement before the model statement. The statement goes like proc phrag data is equal to epi, where type is equal to 2. You will remember that for the transplant types, we had 1 equal lung transplant, 2 equal heart transplant and 3 equal kidney transplant. The rest of the statement remains the same. Finally, for question number 3, where we had to output the maximum likelihood estimate table for heart transplants only, we just run the SAS statement discussed in the previous slide, and it gives us the following table. So here you can see the hazard ratio of 0.854 with a confidence interval of 0.736 to 0.990. The only difference here is that we are using only heart transplant and excluding those patients who had a lung or a kidney transplant.